Hello, you're on a call with Current Continuation, our little SIG Plan podcast where we interview programming languages luminaries. And our guest today is Sarah Chasins, who is an assistant professor at UC Berkeley. And before that, she was a graduate student at UC Berkeley. And she works at the intersection of programming languages, computer-human interaction, and social science. So it's a really broad range of topics, and we're excited to have her here with us. Thank you, Sarah, for your time.
Hello, I'm super excited to be chatting with y'all today. This is gonna be fun.
Yeah, it's great. So should we start at the very beginning? You know, you were at some point an undergraduate student. So tell us about that. You were at Swarthmore College. How did you end up there? How did you choose computer science and so on?
Yeah, so it is a teeny tiny little liberal arts college. I went in planning to be either an English major or a psychology major. And had no plans whatsoever to do computer science. But at that time, they had a lab requirement. And there were many different things that could fulfill the lab requirement, including, going to the chemistry lab or the bio lab or stuff that I didn't really want to do, but also a computer science lab. And I was like, that looks like the one for me. And that was going to be my last science or math class of any kind. After that, I was going to be done. So I was going to check that box. But then it was a blast, right? So I took the intro CS, and they've been incredibly thoughtful about how they shape the curriculum there and about how they shape the TAing program there. They're just so thoughtful about computer science education. They've designed the entire undergraduate curriculum incredibly thoughtfully, including for people who had never seen it before, like me. And so, yeah, it was like all the homeworks there were the most fun that I was having doing anything course related. And I was like, all right, sounds like I'm going to be a computer science major after all.
So you dropped your aspirations to be an English major. Like, was that a hard decision? Or was like, oh
I
yeah.
did drop the English. I kept the psych, so I actually double
Oh,
majored, and I kept the psychology as my second major, which was really
oh,
fun.
nice.
Yeah.
Cool. And
Just out of
then
curiosity, like when you say that the undergrad curriculum was so well designed, do you have
teach
any
us.
examples? I guess I'm just so curious. Like, what is the secrets to like hooking people like that?
I'm going to give you my opinionated take on this.
Yeah.
So they designed the intro sequence with the intention that you wouldn't have seen computing before, wouldn't have seen programming, maybe have no idea what computer programming is. And so every step of the way, they weren't trying to load you up with 1,000 concepts in your very first class. They had the plan that this was probably your first time seeing it. And, they intentionally scoped everything to be the size that you could tackle it. And so a lot of folks did feel like there was some amount of jump between the first class and the second class, and that was maybe a little bit more alarming. But, by the time you were tackling the hard classes, you'd sort of spent enough time in the space that you felt like you belonged there. You knew what you were doing. They had already scoped everything really well in the first couple of classes. And so, it was an incredibly rigorous program, and I learned a ton. And so by the end, you are tackling the really hard stuff, but they're scaling you up, right? It's not the kind of class where you had better have seen it in high school already, or you're not going to be able to get through that first semester. Just sort of ramping up over time.
Yeah. And then I guess by the end you decided you want to go to grad school, right? And
yeah.
So why did you make that decision? How did you end up doing programming language research?
I stumbled into research land pretty accidentally, right? So I was a little I didn't uncover, like I didn't even try computer science until my second semester of undergrad. So I certainly didn't do anything my first summer. My first summer, I just did something totally non-computer science. The second summer, I went to one of the faculty and I said, hey, I want to do something. And she said, you know what? The internships have mostly already staffed, right? Like it's a little late for that, but there's these REU things, these research experiences for undergraduates, maybe try that out. And so I applied, had a really fun time. I spent some time at Notre Dame. That was really fun. And then I enjoyed that enough to go and do it again the next summer. But the next summer, I sort of looked in advance early enough that I was able to think about, okay, what are the things that I'm really excited to work on? So sort of who specifically should I be applying to work with? And I had started to figure out that obviously, all of this was still new to me. I was loving computer science so much. I was just having such a blast in all of these classes. Programming was this incredibly gratifying, satisfying, sort of immediate gratification type of thing for me. I was just loving it. But I was seeing some of my friends, just these really brilliant people who I knew had all of the brains to do it and then all of the sort of understanding of logic to do it. And they just were not enjoying their programming classes in the same way. And so that started me thinking about this idea that, hey, maybe there's not just one way for folks to do programming. Like, obviously, these folks could use programming in some of the stuff they're trying to tackle. They don't like doing it this way. Maybe there's some broader set of tools or languages or some way of expressing the things that folks need to sort of make it appealing and as fun for them as it is for me, right? Maybe there's no one true tool. And so that started me thinking down the line of, okay, what else can we do in programming languages land? And I found Jonathan Aldrich's amazing group, and I was reading their papers. I found some of Josh Sunshine's papers. I thought those were incredible. And so I cold emailed Jonathan Aldrich, and incredibly, he actually replied and said, yeah, you can come work with me for the summer. So
Wow.
that's how I started on that path. Yeah, I got really lucky that he was willing to reply. And Josh was just such an incredible mentor. Both of them were. But Josh Sunshine was sort of my hands-on, he was a PhD student at that time, so he was my hands-on mentor. He was amazing, amazing.
That's awesome. And were you at the time doing stuff that, I mean, I'm sorry to be reductive, but the thing you described is a little bit like in the end user programming type of vision. Were you doing stuff like that over the summer?
No, not right off the bat. So I had started reading these papers because of, getting excited about sort of what is the space of possible programming tools. But what I was working on that summer was type state and sort of what it looked like inside the cloud language, which was really, really fun to reason about. But this was sort of stepping away from that sort of end goal of, hey, what would it look like to make tools accessible to everyone? And just figuring out, what does it even look like to do programming languages work? How do we build programming tools in the first place?
But it sounds like that was convincing enough that you wanted to apply to grad school.
Oh, and it was just so much fun just to be there, right? Like this was my first time sort of interacting with a research group on the regular, right? Because I was sort of off on my own the summer before, but this was a group that was getting lunch every day. And I would come and hang out with them and I would hear what their lives were like as PhD students. And it just sounded like a blast. So yeah, that was very persuasive that, you can have a really fun and exciting time. And, I had started to wrestle with the fact that the stuff that I was excited about, I probably wouldn't be able to tackle as a software engineer. And so that, started to point towards research land, right? Like if I care about making programming accessible to social scientists, there's not really a great place to work on that for an industry role because, you don't make a lot of money off social scientists. And so that started to point to, okay, maybe research.
Yeah. I feel like the critical part of that story is like meeting grad students who are actually happy. You know what I mean? Like what an incredibly powerful thing to like meet grad students who are like happy with their lot in life. Grad school was an incredibly happy time for me. I know it's not for everyone, but it's also awesome that you got to meet people who were like really enjoying it. Yeah.
It was amazing. I think folks should filter for this when they're picking their schools, right? Like to a certain extent, see if the folks who would become your lab mates are happy because you're going to have a lot in common with them. So, it's no guarantee that if they're happy, you're going to be happy. And it's no guarantee that if they're unhappy, you're going to be unhappy. But, some interesting information to have.
Right. So you show up at Berkeley, right? And what was it like showing up at Berkeley, coming from Swarthmore, which is a much smaller school, and now you're in a big state school? Yeah.
It was really weird. Yeah. So, my academic twin came in at the same time, my Popotilimtana, and she was incredible. She was coming out of MIT, right? Like she knew everything and everyone around me seemed to know everything. And so I was trying to figure out what was going on. My undergrad didn't have a programming languages course, right? I had never taken a formal programming languages class. And so I was trying to just figure out what was happening. It seemed like everyone else already knew, and it took me like a year to figure out that, oh, actually everyone else was just pretending they knew what was going on, right? Like I had no idea.
But Mangpo in particular does actually know everything. So
she does in fact know everything. That's true. Yes, Mangpo specifically does actually know everything. That's true. And Mangpo's amazing. She's so great. Yeah. Yeah. So it was very interesting just sort of figuring out how to get your feet under you. It's very, very different setting. And I don't know, I think it's hard to tell, as now being in a faculty role, it's hard to tell exactly the experience that the grad students are having. But I think a lot of folks do have that first year experience of, oh, I feel like everyone around me has a lot of background that I don't. And it's just that everyone has different backgrounds. So everyone's sort of prepped on different elements of the work.
Yeah.
Totally. So I know you have like a pretty broad range of work from grad school, but the first papers of yours that I remember reading were about this sort of demonstration-based programming for web automation stuff. And when preparing for this interview, I was just reflecting on how like the need for that kind of thing since then has only gotten larger. That is like the web has sort of gotten even more complicated and tedious, but also important and stuff. And I'm just curious if you know like where that like general area of research has gone since then. That is like this sort of like without explicit programming demonstrate the kind of actions you want to take on the web type of stuff.
Yeah, there's a lot of exciting work still going on in that space. I think most of it has tended to focus on, all right, well, let me back up for one sec. So the thing that tends to make web automation hard, and especially that has made it hard sort of in the recent past, as opposed to the more distant past when maybe web pages were simpler, is basically web pages are big, messy software. They're highly interactive, right? So you're dealing with this format that's sort of changing quite frequently. You're dealing with the fact that there's a bunch of JavaScript that's running and changing it in the middle of an interaction. You're dealing with the fact that it's actually doing a bunch of server requests out to some other source to get information, pull that down. You're having to wait for that. So there's all this sort of really messy stuff that makes it quite difficult to automate for sort of the general case, right? Like there are very simple web pages that you can automate pretty simply, but for sort of the kind of messiness that you're probably thinking about, and that probably prompts you to ask that question.
Totally.
Unfortunately, that's sort of this really difficult reverse engineering challenge of, okay, let me even figure out which node of this element I'm trying to interact with. And let me figure out sort of which JavaScript I need to trigger in order to make the thing happen. And let me figure out which server response I actually need to wait for in order to get the information I'm trying to get, that kind of thing. So the work that's been happening the last few years in this space, unfortunately, has dropped a lot of the focus on that stuff, on sort of making work that's robust to sort of web page messiness, because it's been a lot focused on what are even easier ways for users to provide the specification, to give us information about the kind of web automation script that they want. And so that stuff is making it so that we have these much nicer, much easier ways of giving a specification for these simple non-interactive web pages. But unfortunately, yeah, you can simplify the interaction somewhat when you aren't trying to handle all of that messiness, all of that interactivity. And so I'm hoping that we'll, swing back towards handling that stuff and making scripts that do handle all of that stuff. And I don't know, maybe I'll swing back into that space eventually. I have a student right now, David Cow, who is working on PDF extraction, which is in sort of a, similar but slightly different space. And so who knows, maybe we can get back into that space.
Yeah, I hope you get to avoid JavaScript at least when dealing with PDFs instead of
PDFs certainly have their own messiness, but
right.
Yeah, at least it's not Ajax.
Right.
And so like it sounded like from your previous description of your time as an undergraduate that your idea of working on programming tools for social scientists started there. It didn't start in graduate school. Is that right?
I don't think it was as well refined as specifically social scientists. I think it was more sort of a broader set, right? I had this art history friend, I had this education friend, I had a sociology friend. So I had sort of this mix of folks who I thought, I could see them running into cases where they needed programming and where sometimes they would come and ask me for programming. And so I had the idea of sort of this broader mix of folks and the tools that would work for them. But I don't think I had refined it quite to
So you show up, you start working with, I guess, Ross Bodick, is that right?
Ross Bodick, my incredible advisor.
Yeah. And so you convinced him that I'm going to start working with social scientists, and he was like, yeah, cool.
No. So Ross was an amazing, incredible advisor for me for so many reasons, but truly probably the number one is he let me do the weird stuff. So like he just like, if I wanted to go off and do this wild HCI thing, right? Like he's a programming language person. He doesn't have to let me go off and do weird, crazy HCI stuff. But he did. He just like he was totally on board for this. And in fact, the specific web automation stuff that we started doing, so this was with my amazing friend and collaborator, Shaun Barman, he and I were working on this just straight record and replay, right? Like, so years and years before, Ross had actually worked on, if I'm remembering this all correctly, and this was a long time ago, so please excuse any memory errors, but Ross had worked years and years before on trying to handle web automation stuff. And it was too hard, right? Like they couldn't even get to the point of reliable straight line record, give me the straight line replay script to do that same thing as the web page is changing, that kind of thing, right? Like it was just so hard that they eventually sort of dropped it. But then Shaun Barman and I, we had been working on the sort of record and replay layer, and we had figured out a situation. We figured out a tool that would be robust for that sort of straight line record, straight line replay situation. And then we were starting to, well, okay, then Shaun graduated. But then I was starting to think about, okay, what would it look like to actually put this in people's hands to collect large data sets or to do data entry for large data sets? Like if we can get a recording of a small part of the task and generalize it to a large part of the task, what would it look like to actually give users that tool? And bear in mind, I had come in through programming languages land. I was getting a programming languages PhD. I really, again, my undergrad was very small. We didn't have a programming languages class, but we also didn't have a human computer interaction class. I didn't totally know what human computer interaction was. And so I did not have the formal training in that or all of the tools that I should have had at my disposal. But I was like, I think I kind of would benefit from talking to real users about this at this stage, right? We're going past just the record and replay thing. We're starting to think about, these bigger scripts. I don't even really know what bigger scripts people want. Like, let's maybe talk to some folks. And so Ross said, I know this person through like my kids' daycare. You want to like talk to her? And so we had this amazing chat with Susan Stone from the social welfare department, who was sort of the first person I was chatting with. And then that sort of we ended up sort of not going down that path, because then we actually all moved up to Seattle, right? So Ross moved from Berkeley to Washington. And so we all moved up to Seattle. And so we sort of stopped working with Susan for a while. But at that point, I had started to actually get together a tool that was doing sort of this generalization process. And so I was trying to figure out, who do I test this with? How do I figure out if I've landed on something that's going to work for folks? And I was just sort of asking around in the computer science department if anyone had sort of any kind of mailing list in mind of people who maybe would need web scraping or web automation of some kind. And someone said, oh, I know this mailing list of people who are, interested in things related to cities, right? And it just has all the various departments on campus where someone might be interested in things related to cities. Maybe you could mail them. And so I just sent out a mail and said, hey, does anyone need anything like this? I was trying to put together a benchmark suite, and I wanted it to be a benchmark suite of actual tasks and not just tasks that I had sort of made up. And so, yeah, I sort of put out the call, like, does anyone need anything in this general space? And was kind of flooded with replies. And yeah, a few of those turned into really amazing long-term collaborations.
And as a result, like you ended up writing social science papers, right?
Yeah.
So like, I guess one is like, how hard was it to work with the social scientists? Don't worry, they're not gonna see this. So, and then like, what was the paper writing process like? Because I've like heard of computer scientists like writing law review papers, and it's like a completely different world. And so I'd love to hear about that.
Completely different world, like a so much harder world. Yeah, I mean, so it was amazing because my collaborators were absolutely incredible. It was just, yeah, I worked with a ton of different people, but especially there was this amazing sociology professor, Kyle Crowder, and his student, Chris Hess, and they were just absolutely incredible. Chris Hess is now faculty. They were amazing to work with, but yeah, everything about that paper writing process was different, and at least for me, much, much harder. So, it starts with, for one thing, you're writing the paper in Word, not LaTeX. This was very alarming to me at first. We're just doing this in a Word document, and we can do that. But no, like, I mean, thinking about the roles that conferences serve for them, the roles that workshops serve for them, that journals serve for them, like all of that is totally different from how it works in computer science. So even navigating that in the first place is really hard. Obviously, what they consider contributions, what they're excited to see in a paper is just dramatically different. The kinds of details that you need to make clear in the writing is just a whole other story, right? Like the kinds of things that have to be clear in computer science papers don't have to be clear in, say, sociology papers, and the things that have to be clear in sociology papers don't necessarily need to be clear in computer science. Like there's just, it's a totally different world, and it's really, really hard.
Sorry, this is like too blunt of a question, but like, like, how did you convince these people to collaborate with you? It's like sometimes even when like the potential collaboration would be awesome, it's just sort of like this barrier of like, who has the time? We already have so many things going on. Do you have any sense of like, was it just like so compelling that like people couldn't resist, or did you catch people at a particularly like opportune point in their careers or something? I don't know. Do you have any advice for other people trying to do the same thing?
I do have advice for other people trying to do the same thing. It is different from what I actually did. So I did a little bit of, well, all right, let me just say what the advice is. So the number one piece of advice is to have picked a problem where solving it actually helps people, right? Like, and this kind of seems obvious, and yet this is actually something that often we don't formally sit down and think about, okay, who is this tool going to help? How is it going to help them? How does it fit into their existing work practices? Is it going to disturb other work practices? Is it going to fill a gap that they recognize that they have, right? So maybe we'll dive into this later, but I'm a huge believer in need finding work and the idea of studying users in order to even figure out what problem you should be solving. I did not do that formally, but as I mentioned, I had sort of done some amount of sort of chatting to people and figuring out what their needs were, just sort of casually, informally. And so I had basically stumbled without knowing HCI at all into some kind of unofficial need finding work. And I had started to figure out, okay, this is a real need. This is a real need. It had better meet these goals, right? And so when I was coming to these folks, I had built something that was actually going to be really useful to them. And so, yeah, it was just a matter of, they knew they needed to collect large data sets. They knew those data sets were available on the web. I was offering them a way to do that without having to learn how to do programming first. They were on board, right? That was going to be cheaper than, you know, hiring an army of high school interns to sit in front of Excel and copy stuff out like manually, right? So yeah, it was really a matter of, you know, through my very unofficial, you know, poorly and unknowledgeably done need finding work, I had landed on something that folks actually needed.
So I have to admit, I haven't heard this term need finding work before. I mean, it's intuitive what you mean by it, but I guess I'm just curious, like, could you illustrate a little bit more about what you mean? Like if you had approached that more formally, like what that would entail?
Definitely. Yes. Okay. So this is one of my favorite things to talk about with how HCI and PL can interact. So I think so often if we think about, and I certainly thought about HCI this way when I first did start learning about HCI and did start integrating some of those ideas. I was like, okay, I'm going to spend my 1 year, 2 year, however long building my system. And then at the end, I want to figure out if it works for users. So then in the evaluation, I'm going to run a user study, right? That's where HCI fits in the pipeline. That's what I believed. And so now this is just totally wild to me that I ever believed that, because of course I should first figure out what problem to even solve by, you know, figuring, okay, so let me go in and study the kinds of things that people are trying to do and can't do with the tools that they already have, right? If an existing tool is already covering for them, maybe they don't need me to come in and handle this. If they are already really happy with these elements of their tools, but there's some gap over here where it's really causing problems, right? Like if you go and just watch people trying to accomplish tasks, and there's tasks that there's any chance that programming might actually help with those tasks, you're almost certainly going to understand more after watching people. You're going to understand more about what kinds of problems would be useful to solve. And so usually the research question for a need finding study is for a particular audience X, when they're trying to do task Y, what sorts of problems are they running into, right? That's the kind of research question that we'd answer in a need finding study. And at the end of a need finding study, now I'm ready to sit down and write out, okay, here's my research problem. And then maybe in the course of coming up with it, now I like, once I know the problem, okay, off I go, I'm going to do a bunch of brainstorming, right? Maybe now I have 20 ideas of things that I could actually study, that I could actually try to build. Maybe I want to now do some formative research where I'm going and putting some prototypes of some of these ideas in front of folks and figuring out if those work for them. Or maybe I just want to see if like they can actually provide the information that would be needed as the specification for the programming tool that I'm thinking about, right? So let me just go and quickly like sit someone down and figure out, if I give you this set of instructions, can you even produce the information that would be required for you to use the tool that I have in mind, right? So that would be formative research. And then so that's basically like, once I've picked the problem, right? I've already picked the problem that I'm trying to solve. Let me figure out what are some paths that are promising en route to a solution. And then once I've picked the problem and I've picked the solution, then at the end of that, I can do some evaluative work where I say, oh, okay, like, did I actually succeed in solving this problem that I was trying to solve? So it's sort of this thing where, to me now, it's so natural that I want to be going and seeing sort of what information I can collect about the audience that I'm trying to serve throughout. And so when I sort of think back on that mindset of, let me go and do some engineering for a couple of years and then I'll do a user study, to me that feels like, okay, I'm in an unfamiliar city. I have some idea that there's a place that I want to go. I'm just going to go out and start walking. And at the end, I'm going to open up my map and be like, did I make it here? Right? Like, that's what it feels like to me to just do only evaluation with users. Like, I could have looked at the map before I started out and figured out the route. I could have, when I got to a confusing crossing, I could have looked at the map then to figure out which way to turn, right? I don't need to just sort of walk out into the city, land a place and say, did I do it? Like, I can do something a little more thoughtful. That's my pitch on Needfinding.
So I guess we can, I mean, you in your communications of the ACM paper in 2021, you wrote a paper about PL and HCI better together. So I guess this kind of riffs on this idea. Like, what is your vision? Like, how can HCI impact PL? I guess you kind of described it in some sense. But how can PL influence HCI research, and what are the obstacles there?
Yeah, we thought a lot about sort of what lessons we wanted to sort of highlight for each audience, right? What should PL be drawing from HCI? What should HCI be drawing from PL? And it was very interesting because we felt like there were some things that folks had already actually picked up. And so we didn't sort of bother to harp on the things that we felt like were already sort of in the mix, in the air. But I think the big things that we were trying to get folks to think about with if they're in HCI and they're thinking about borrowing some tools from programming languages, the big thing that we wanted folks to think about was basically, you can give your users sort of additional power to do uncommon things if you give them a programming tool, right? The interfaces, the graphical user interfaces that folks often build, often you have tried to figure out, here are the common things. And I'm going to make it really easy to do these common things. And that's really powerful. And it's definitely really, really helpful for so many use cases, obviously. But it also means that, okay, if this user wants to go off and do this uncommon thing, that might not actually be possible, or it might be very difficult, right? And so the idea that, hey, a programming language is also an interface that you can give them, right? That is another option. You don't have to necessarily show it in a textual programming environment like folks might be used to. You can show it in a visual programming environment or some other kind of environment. There are things that you can do that will make programming less scary to your users while also still giving them, the power of composition, the power of not having to, control the control flow manually, right? Like in a standard graphical user interface, the way that you decide the operation that runs next is, I've opened one of these 10 menus and then I've clicked on one of these 10 options. Like, that's a pretty frustrating way to direct control flow, is to just be you doing it as a human. You can actually give folks something a little bit more powerful if you're able to find the right abstractions for them, if you're able to give them the programming language. Which is not to say that, we should never allow manual control flow, right? Obviously, we actually even have programming interfaces where we're allowing that. If you think about what a computational notebook is doing, right? Choosing when to run this cell versus this cell versus this cell, that is also giving folks manual control over control flow. And so it's not that we never want that kind of thing, but, in that context, you also have standard control flow within your cell, and you can do whatever you want in there, right? So, I never try to say, oh, this is the right answer for every programming audience, for every whatever. But again, thinking about, okay, what are the bigger, broader, more diverse set of programming tools that we can make available? There are a lot of cases where we might first, as HCI researchers, reach for something that looks more like a graphical user interface, and we can reach for language instead. And then we talked a bit about what are some of the sort of guardrails that you can offer to folks. We talked a bit about the nice new technologies for building DSLs and how much easier that's gotten for folks. So there are a lot of sort of practical lessons we also wanted to offer about how people can actually be making programming tools available. We pointed a bit to the exciting work in program synthesis. I'm obviously a program synthesis person, and so I like to think about that. And so, oh yeah, this was joint work with Josh Sunshine and Elena Glassman. This was something that came out of, we run a workshop called Plateau that we run every year, that's on this intersection of PL and HCI. And so it was all three of us sort of putting our heads together and thinking about, okay, what are the technologies that we feel are much easier for folks to actually use now than they would have been in the past, and let's make sure that HCI folks know that those are available.
That's really cool. I really like this notion of like the power to accomplish uncommon things. It occurs to me that like when you're talking about the sort of composition that makes up little, even small programming languages, by the nature of there being a combinatorial explosion of like possible programs you can write, by definition, everything is an uncommon task, if you know what I mean. Like there are no common tasks. Everything is like sort of divided. There's this like dimensionality thing. Anyway, so that seems like a really great framing.
I think it was very interesting to talk to HCI folks afterwards. They, we're often thinking about this trade-off between sort of agency and enforcing conditions that we as the designers want to be true. That's something that obviously we're thinking about as programming language designers as well, right? There are often programs that we are intentionally putting off limits, right? What are we doing with type systems if not that, right? So that is a huge part of what we're thinking about, and also a huge part of what the HCI folks are thinking about, this trade-off between where do I want to put up guardrails? Where do I want to say, no, I'm going to enforce that this precondition has to be met because otherwise this analysis isn't going to be valid, right? So where are you doing that versus where are you saying, oh, actually, I'm not trying to put this interaction on Rails. I want them to be able to sort of go off and do the weird stuff. And I think because of being so often in graphical user interfaces land, it's really tempting to go more in sort of the guardrails direction and more on the like, let me put you on the straight and narrow path, right? And so this was a really exciting set of conversations for us to have of, hey, like the uncommon things are important too. And it's really frustrating to be trapped in a graphical user interface that is not letting you get that last 10% done that you're trying to get done.
That's really cool.
It was fun.
So we've touched upon your programming languages research, your HCI research, your work with social scientists. How do you do it?
As
how
with
do you
so
keep
many
all of
things,
this stuff in your head? How do you keep, track of all the literature? It's just a lot of stuff.
I think the main answer now, really honestly, is
Yeah.
I just have an amazing set of students, right?
Yeah.
I'm so incredibly fortunate in my PhD students, my master's students, all of my students. And so that lets us explore these very, very broad areas because the students are so capable of sort of getting into a space and getting up and running, right? So I currently have one student, Justin Lubin, who's embedded with a biology lab, right? So he's embedded with the Nunez lab here on Berkeley and also with the Preda's lab in UCSF, right? He's literally in the lab pipetting, right? I don't know enough bio to do any of that, but he is figuring out the programming needs by being right there with them. And it's already led to at least 2 programming languages projects, right? And then over here in just sort of a totally different space, my student Parker Ziegler is embedded with journalists, right? He's at this climate journalism organization called GRIST. And, he's getting credits on stories. He is interacting with them directly and figuring out their data needs, their geospatial analysis needs, their geospatial visualization needs. How are they trying to do cartography, right? So all of that is then going and feeding into the work that he's doing on building direct manipulation tools for cartography, right? So I don't have the expertise in geography that Parker has. I don't have the expertise in bio that Justin has, but because they're all just so amazing and so awesome at sort of going off in these spaces and bringing back the PL lessons, we can sort of keep all of these in one lab. And the really exciting thing to see has been just how much they have in common across these different spaces in terms of the techniques they're applying, right? Because even though they're applying them in these incredibly different spaces, what they need to do in order to figure out the programming needs is pretty surprisingly similar, right? And so they're very much in conversation with each other about sort of how they are doing this process of working together with these folks, what it's going to look like to try to introduce programming interventions with them, right? So all of this sort of process side of it, you know, it's drawing on programming languages and it's drawing on HCI, and it's true that keeping track of both of those literatures is a lot to ask of them, but they're able to sort of use those fundamentals across all of these different spaces of different collaborators.
So beyond biology and climate reporting, you also have a not that old result that's kind of like on the home turf of programming languages. Just like a few years ago in Uppsala, you have this paper about sadly typed functional programming and like how programmers interact with that. So like, let's put aside biology and stuff for a moment. I'm curious, like how you got interested in this kind of like this again home turf type of stuff, and if you can tell us what the findings were, that would be super awesome.
Totally. Yeah. So full credit for that research question goes to Justin Lubin. So who is actually the one who's engaged in biology research now. So, you know, connections. Yeah. So he came in just really interested in that. And we looked in the literature, and it's incredible that, you know, I certainly still feel that we haven't done enough studies of programmers. There's a shocking amount that we don't know, but there is certainly a pretty large literature at this point. There have been many studies on programmers, and it's incredible just how little there was of statically typed functional programmers, right? Working statically typed functional programmers, experts in that space. There's some on students trying to use functional languages, but really there's not a ton in this area. And so we were looking around trying to figure out, you know, what do we even understand about how they're writing programs? There's so little, there's all this common wisdom, right? We share it amongst ourselves, we're sort of passing it around. And there are people we sort of look to as experts, and they will say things and we'll nod along. But we sort of hadn't studied it as a community. And so it was this really fun thing where we did sort of this two-phase qualitative and quantitative work. So the first was just in doing contextual inquiry, looking at folks just doing programming tasks, right? Just come in, and I think it was on Zoom, so it wasn't technically come into the lab, but it was basically come into the lab and do these tasks, right? Looking at what was happening, looking at some folks live streaming their functional programming tasks, statically typed functional programming tasks, looking at what they were doing, right? And then drawing some lessons from that, right? Doing this, there's this type of analysis called grounded theory analysis, qualitative data analysis, very difficult. Very, very difficult. One of the harder things that I ask my students to do, and often very intimidating in their first years. So we'll maybe set that aside. But so he did that, and he developed the theory of what they were doing. And then we picked out a few of those hypotheses that we were really excited about and we really wanted to test. And we set up some controlled experiments for those. And we found some really interesting stuff. I'll maybe mention two things because there's so many findings in there. I can't dive into all of them. But one of them was, you know, the way that we talk about a compiler, usually what we're talking about is, okay, the programmer's going on, they're writing their program, and then when they're ready to run it, you know, then they're going to go ahead and run the compiler, and the compiler is going to turn it into the ones and zeros, or however we're explaining it, given the particular audience we're talking to, and then they're going to be able to execute it, right? That's sort of the flow that we talk about most of the time when we're talking about compilers. And one of the things Justin realized pretty early on was people are constantly running their compilers when they're not expecting to get an executable out the other end, right? Like they're not trying to just run the code. They know it's not ready, right? They're using this as basically this to-do list, especially in this static type functional programming context, right? They're using it as this to-do list of, okay, here are all the different places where I need to go back and fix up the types, or here are all the different places where I need to go back and make sure that we're handling this case, right? That kind of thing is a great thing for a compiler to be able to communicate to you, because so much of that information is right there in the program. So of course it makes sense for us not to have to try to keep it all in our heads. We can go ahead and take advantage of the fact that the compiler is essentially keeping track of that to-do list for us. And so we had this hypothesis about how many times are people running the compiler thinking that they are actually that they're ready, that it's correct, that it's ready and good to go, versus how many times do they know perfectly well that it's not ready, right? They're not trying to just use it to get the compiled code at the other end. So that one was really fun. I'll mention one more just because then Justin did a follow-on project where he actually introduced a whole new synthesis technique on the basis of the needs from this other finding. So he figured out that folks were often writing pattern matching code, right? They were finding that, you know, straightforward to write, and they were choosing to write it in that way. And they were saying, oh, I'd actually prefer this to be combinators, but like, you know, I'm not going to bother. Like, I want to be writing it in pattern matching style, but actually I'd really rather this be expressed in combinators. And so Justin then did this follow-on project that he presented at the last PLDI, where it was basically a work where the input to the synthesis tool would be direct style, no combinators programs, and the output on the other end would be programs that actually are using combinators, using some components from a library. And he had this really cool idea of equivalence-based, canonicalization-based equivalence, where you can figure out if a certain sort of skeleton based on combining a bunch of combinators, you can figure it out if that's going to work by applying a canonicalization function. You leave holes in it, or you apply a canonicalization function. You can think of that as basically a bunch of sort of standard compiler optimizations like deforestation, whatever. You can go ahead and apply that in sequence to a bunch of different candidates that are using various sort of skeletons of combinators. And then you apply the same thing to the input program, right? Your direct style program that's not using combinators. So apply that same sequence of transformations. And then over here, you see, can we unify? If we can unify, fantastic. We found the match. We can go back to the version that hadn't had canonicalization applied, right? The version that's just the mashup of various combinators. Go ahead and fill in all those holes based on unification. Off you go. A really cool technique.
That's pretty cool. I like the first finding. I mean, it resonates.
It's right, isn't that? Yeah.
I mean, like people are using compiler as a linter essentially. But now,
Exactly.
I guess Rust, for example, is like, there's the Rust analyzer, which is kind of a lightweight compiler. So I guess it's a.
Or even just cargo check, the fact that you can like run the type checker without even generating any code when you know that you don't even want to, you know.
Yeah.
Even if you think about some of the things that our programming environments are doing for us, right? Basically, they're running little mini bits of the compiler and just surfacing that immediately before you even, press a button or run a line of code, right? Like it's keeping track for you of, oh, okay, here's what I know about the types right now.
Cool. And I guess a related paper, maybe not very related, but in a sense, you're studying in how domain experts use an embedded DSL. Now you're studying non-traditional programmers using a DSL. So what's going on there? Like, how do they use embedded DSLs?
This was so much fun. Yeah. So one of my favorite things to find out in this kind of work is sort of places where the common wisdom is actually maybe leading us astray. I think this study was a perfect example of this. So this was my student, Lisa Reynolds, who was my master's student, but was actually a PhD student in a whole other department. So she comes from this climate economics background. That's sort of her main area. And she's one of the main developers of this tool called Mimi, which is a library embedded in Julia for basically a certain kind of climate economics model. And there's a ton of users in government, there's a ton of users in academia, right? Practitioners, like there's all these folks in sort of doing policymaking type stuff that really matters who are using these models. And so she really wanted to make sure that these models are usable for them. And so she would be coming to me with these questions of, okay, how do we actually make sure that a library inside an existing host language, what are we supposed to do to make this more useful for folks? Folks are running into these weird things about Julia, which is the host language for this, right? They're running into all of these sort of weird issues, and they'll only go to the Mimi specific forums and resources. And so then we're realizing that we have to explain all this. Julia, she was like dealing with all of these questions about what should I be doing as I'm developing this. And every time she was coming to me with that, saying, you know what, no one studied that. We don't know. And we don't have the answers. No one has looked at it. And so we went and actually looked at some of the users. And I think my favorite finding from that one was there's often this advice about developing an embedded DSL that you should blur the line between the host language and the embedded language, right? This is a really common piece of wisdom. And it kind of makes sense, right? Like maybe you don't want to sort of distract folks with where that line is drawn. Like maybe you want it to look a lot like the host language. So I can see where this is coming from. But one of the big things that we found in that study was that this is super confusing to users when they are especially trying to debug, right? So things as simple as, do I now go to the Julia documentation versus do I go to the Mimi documentation, right? Am I trying to ask this question in a form devoted to the host language or the embedded language, right? All this sort of, where should I even look for information about how to solve this problem that I'm having is really complicated if you don't know if you're working with the host language versus if you're working with the embedded language. And so that was the kind of thing where, you know, it goes against the common wisdom. It's not what we expected to find. But yeah, it was really interesting to see, oh, maybe actually make it really clear where one begins and one ends. Maybe that's actually more valuable for these users.
That's pretty interesting.
Totally. We actually read this paper in the PL discussion group at Cornell last semester, and I remember really liking this specific finding. That is like the thing that, like, well, maybe reconsider this whole like blur the line thing. It's one of these things that seems like incredibly intuitive in retrospect, that you'll like,
Right.
you have all these problems where like programmers won't know where the boundary is, and they'll expect more things to work than actually do, and this type of thing. There's I think there's some really useful lessons in there.
There was this related finding that we were finding that if the syntax looked close, but wasn't quite exactly a match with the syntax of the host language, which, they were doing a bunch of macro stuff. They're doing all kinds of really cool stuff in Mimi. That can really run you into problems, because then it will look close enough to the host language syntax that folks will assume they can do host language things, including, not just the programmers themselves, but even their linters, right? Will assume they can do all kinds of things that actually maybe they can't do with the language of your own embedded language. And so, yeah, it was really interesting, this idea of how close do you want to be to the host language? How much do you want to look like the host language and appear to the programmer to be the host language? It was fun.
So if you don't mind continuing this kind of like rapid fire switch between domains here.
Yeah.
We also wanted to talk about your fact paper from last year, where you about this document organization tool and about transparency. So this is, of course, fact being about fairness, accountability, and transparency. This is like yet another domain for you. We'd love to hear the story of that paper and how you got interested and what the problem looked like.
Yeah, so this is an amazing paper that my student Helena Hadonugatu did. So a little context on this is that I actually run I co-direct one of these 5-year labs here at Berkeley that are pretty common in especially systems and systems adjacent areas. So my colleague Aditya Parmeswaran and Jill Hellerstein and I were all co-directors on one of these. And the goal of this particular lab is to work on data work tools and programming tools for basically low resource teams touching on important societal issues, right? So if they're working on social justice adjacent work and they have some kind of data work need or programming need, we are probably interested. So this is a really fun space where we ended up meeting a lot of interesting people, right? So one of the folks in the course of working on that who we ended up talking to was this amazing journalist, Lisa Pickoff-White, who was at KQED, which is the sort of Bay Area NPR station. And she was dealing with all of this police misconduct data. But the data was, it wasn't something where, they weren't sort of happily handling this over in a really nicely organized format, right? The sort of story that I've heard for sort of what is conceptually going on here is, first they walk into a room, throw all the pages up in the air, grab it back together, scan it, hand it over, right? Like, it's not really intended to be easy to consume. This is not necessarily, So dealing with that data, we expected to go in there finding some amount of sort of PDF extraction type needs and, all of that stuff is real, but she was also like, hang on. Before we even get there, organizing these documents is incredibly hard, right? So something as simple as if I have this, 2,000-page PDF, where am I supposed to, chop that into pieces to say that, okay, this goes with this case, this goes with the other case, right? All of that is actually really difficult. What if I have, the hospital report over here, and then the COPS zone internal report over here, and then some kind of court records over here, right? Like, I need all of those to be grouped together. How do I figure out that all of those should be put into the same bucket and all these should be put into some other bucket, right? All of that work turned out to be just incredibly difficult for them and was the barrier that was standing out even before getting into, okay, let's grab some data out of it once we know what is associated with a given case. And so this led us down this path of working directly with her on a document organization tool. And one of the things that I was really excited about with that work, there are a couple of things that I really liked about that work. One was that process of working really closely, doing this co-design. And one was we ended up at the end presenting the document organization tool in a bunch of different programming paradigms. So we showed it in sort of traditional text-based programming, we showed it with programming by example, and we showed it with a visual programming interface. And by the end of their third task working with this, they were basically just as fast with any of these, right? Like text was intimidating at first, but after a while they got used to it, right? If you provide the right abstractions, then by the end, folks are going to be good to go, even with, you know, something that might be intimidating at first. And so that was a really interesting finding for us.
So let's shift attention to you know, the LLMs in the room, I guess. So,
Always a fun
you know,
topic.
right, yeah, yeah, like I mean, I guess, you know, LLMs probably like impact your work a lot, right? Like because you study programmers and or anyone who uses programming languages or programming tools in any capacity, right? And at the same time, you work on program synthesizers, and I guess LLMs are impacting both. So let's start with programmers. So we have like professional programmers, we have novice programmers, and domain experts. Like, how are you seeing generative AI changing their workflows, and how do you envision it going forward?
It's so interesting. I teach this this class usually about once a year that's on building user-centered programming tools. And in part of it, I have students go out and do need finding work with some audience. And, you know, 2 years ago, all of these were like these incredibly domain-specific results. And, you know, they were saying, oh, when I'm looking at these folks, here's what I'm finding, right? And I would read over these reports and be like, oh, that's so interesting. I never would have thought that's what Arduino programmers are running into, right? And then this past time that I asked it, everyone had like a third of their paper devoted to the ways that people were trying to use ChatGPT to solve their problems and the ways that this was failing, right? Like, is this need finding work? And so they're looking at what are the problems that people are having. They're reporting the things that were really hard. And so they're all like, yeah, they spent a lot of time trying to make ChatGPT write this and it wasn't writing it. All right, so you start to see this piece that's sort of repeated across all of those write-ups. But yeah, so obviously I don't work a ton with folks who are sort of professional programmers, but it looks like at this stage, basically, if you are an expert programmer, right? So someone who already knows how to do the job without the LLMs, and if you're already familiar with the code base, you can probably expect that you will get about 10 to 15% faster, depending on the type of project you're working on, the type of code base that you're working on. You might also have more of a fun time, depending on what you define as a fun time. So that's sort of what we're looking at for the professional developers. For the domain experts and the non-programmers, unfortunately, it's a bit of a harder story. So there are definitely places where these LLM-backed tools are working well for them. So in general, if you can expect to Google the kind of thing that they would Google and get back the program, ChatGPT, LLM-backed Copilot, whatever, like that should all work for them in those situations. But if you think about sort of what's in the training data, right? There's all this training data of here's a program, and here's the kind of text that a programmer would write about a program, right? That's sort of what's out there on the web, right? Because it's the programmers who are writing the program, so they're the ones who've sort of written about what that program is, right? The sort of English that's nearby is the English that a programmer would write. And so then if you try feeding in the kind of English that a non-programmer would write, unfortunately, that does not always get you something particularly useful. This ties into another one of the big challenges, which is, in general, if you look at how programmers are using these LLM-backed tools, typically the programmer is still the one who is doing problem decomposition, right? And this is a huge part of what makes programming challenging, is to decide, okay, how am I breaking this problem down into the sub-problems that I'm going to sort of solve? And so if you look at what's happening with programmers using the LLM tools, they're still the ones doing the problem decomposition. A non-programmer who hasn't had formal programming education has not been trained in how to do that. And so unfortunately, that is also a big stumbling block for them. And then even say we manage to get over both of those issues and we do get out some program, if I get out 50 lines of, choose your favorite programming language, I can look at that, right? I have the programming training. I can look through. I can say, okay, yeah, I'm confident that this is doing what I want it to do, or, oh, I'm confident this is not doing what I want it to do, and here's the parts I'm going to change, right? That's all good. For a non-programmer, for a domain expert, unfortunately, that is not gonna fly, right? They're gonna see that and they're gonna say, maybe, and maybe they'll try it on 1 or 2 inputs and they'll say, okay, it works on that. But yeah, unfortunately, building the confidence that the thing you've gotten is a thing that you should trust, that is doing the stuff you actually need it to do, we don't have a good answer for that right now. So I think it's obviously a super useful building block. Putting it inside other tools seems super helpful, but sort of these just natural language in, natural language out type tools don't seem to be the answer on their own, at least so far. Maybe that changes going forward.
And how do you see it changing program synthesis? Like most of traditional program synthesis has been enumerative, including some of your work on like web automation and others. And now you have LLMs, which can give you long enough snippets that you can potentially stitch together, or even they might solve the problem straight up. How do you see it changing program synthesis landscape?
Yeah, I think my favorite uses of it inside program synthesizers are basically as a bias, right? So you can see cases where folks are saying, okay, let me generate, like obviously, like if it does something that actually meets the specification, fantastic, like call it, right? Like in program synthesis, we are benefiting from the case of actually having a specification and deciding that any program that meets that specification is good enough. That's usually the only guarantee that a program synthesizer is offering. Not always. Usually that's the guarantee that we're offering, is that whatever program is coming out the other side, it meets the specification. So if it meets the specification, who cares how you got it? Like, great, fantastic, call it, we're happy. But of course, very often it does not meet the specification. And so what do we do in that case? I think the works that are really exciting in this space are basically saying, okay, maybe it's not the right program, but maybe it has some ideas about components that would be useful. Let's maybe bias our search to first search more quickly in the areas that sort of would lead to these little program snippets. And so let's maybe see if we can go down that path before we go down this other less likely path. But I think that stuff is really promising. I'm also actually really excited about using tools like that as baselines, right? So it's really often very hard to do a fair controlled study of tools in these spaces, because often you're trying to tackle a synthesis problem that actually hasn't been solved before. And so, what is your baseline? It doesn't seem fair to just say, oh, okay, off we go, like this is what our tool does, and we tried to make this other tool that's actually trying to do this totally other thing do it, and it didn't really work well, right? Like that doesn't really seem super fair. So because this is a very general purpose tool, it's nice to have it just to sort of throw in as a sort of acceptable baseline.
That's really interesting. You really got me thinking about this like difference in the tools to build for like professional programmers versus like end user stuff. I think it's really interesting to ponder. Like it's just so interesting that like in my anecdotal experience, like people who are experienced programmers are really comfortable with like the uncertainty and constantly correcting Copilot. So like the very straightforward version of code generation tends to be like tolerable in a way that wouldn't. And I think it's really interesting to think about like about having to take sort of more sophisticated approaches if you're going to be building for people who are not expecting to, who isn't literally their job to be like fixing broken code all day.
Totally, yeah. Yeah, and this is one of the interesting things is when they've done studies of people sort of accepting things like Copilot suggestions, right? Often they're accepting them just to kind of look at them for a second, and then they get rid of them, right? And then they write the thing that they actually wanted, right? This is sort of this standard mode of interaction, right? It's helpful for folks to have this is like, I think of it like this thing of, have y'all ever heard the advice that if you want to get good programming advice on the internet, instead of just posting the question, you should post the question and then post a wrong answer to that question, and then everyone will pile in to correct the wrong answer. So I think it's sort of like that, right? Is the programmer wants to see this thing that's wrong, they'll be like, oh no, that isn't actually what I wanted. Like that's a nice starting point, but I actually want to go back and do this other thing. And that's great if you're a programmer and you can just sit there and write the code, but that's not really a super good interaction model for someone who, isn't comfy writing code in the first place.
So do you mind if we like return to the career stuff? So you have the vantage point of having been an assistant professor for a little while now. Can you tell us what it was like starting as an assistant professor? You can tell us what was great, what was hard. I guess we'll get to the advice later, but just can you tell us your experience of getting started?
Yeah, we're too old. We don't remember.
I know you remember. You are not old. Have either of you ever grown mint in a container?
No.
Mint goes absolutely wild in the Pacific Northwest. So like, I wouldn't dare to try.
Right. So mint is going to try, like, it's going to take over the container that you put it in. It's going to take over that other container next door and the other container next door, and also some stuff that's not a container and you didn't think it could take over. That's meetings once you start as faculty. And so you got to get good at weeding, because the meetings will try to take over your calendar. And it's sort of the biggest thing that I noticed in the transition was just, it's really easy to end up feeling more distant from the work and feeling like it's hard to get into the nitty-gritty, because there's just so much of your day that is blocked out for stuff other than sitting with your research. And when you're used to, you've just been a PhD student or a postdoc where you were through classes, and so you're getting to spend all day thinking about your one project. And now you are thinking about 40 different things that different people are asking from you. And realistically, you're going to be able to do 30 of them. Which ones are you going to sort of drop on the floor? Which ones are you going to, do at a B+ level? Which ones are you going to do at an A+ level? It's that, I think that juggling and the way that your time just gets sort of spoken for is the biggest difference that I noticed. But the mentoring aspect is so nice to get to take mentoring seriously, right? Often in PhD situations, to a certain extent, mentoring is valued for a PhD student as sort of training for eventually being an advisor. But to a certain extent, I think there's some subtle messaging that maybe that's a distraction. Maybe it's distracting you from your research. And getting to sort of take that part of the work really seriously and sort of understand that that's core, right? Like, one of the best things that anyone said to me, I wish I remembered who told me this, was that if you want to make research, go to industry land. If you want to make researchers, go be a professor. And so having that mindset switch of thinking about, okay, like, my job is to make researchers, right? My job is to be there for my students and help them achieve their goals and their dreams. That was really, really nice. Yeah.
I guess what advice do you give new faculty other than be good at reading out?
I have so much stuff that I would say. Okay, so number one is, this is going to sound so silly and so small. Your very first year, you have a little more time than you're going to have going forward. I know you don't think that, but you do. And so put the coffee dates on the schedule now. Put the recurring coffee date on the calendar, right? You should be hanging out casually and socially with other faculty. And if you wait until the second year, you're going to feel like you're too busy and you're not going to feel like you can carve out time for it. So don't wait until the second year. Put it on the calendar in your first year and make sure that, whether it's a peer, whether it's someone a few years ahead of you, whether it's someone who's super senior, have those recurring chats with your faculty friends. I believe in that a lot. When you're picking your first students, everyone thinks a lot, of course, about research fit. And I do think it's important, but you're probably going to get it wrong your first year. You're probably going to realize that your research interests are different than you thought. So, and also their interests might change. So, work focus on that, but also think about the fact that they are setting, that first batch of students is setting the culture for your research group. So make sure you trust them to do that, right? Like, you are going to be chatting with these folks for 5 to 7 years. Your other students are going to be chatting with these folks for 5 to 7 years, right? Make sure you trust these folks. Another thing that I was told, this might have been Zach Tatlock, I don't remember for sure. I think it might have been Zach Tatlock. But the message for new faculty was, you are scary now. Like, you think inside you are the same person and you're not scary, you're just a person. Obviously you're not scary, but all of a sudden you do actually have a ton of power over so many of the people around you. It's really easy to end up in situations where that power is working without you even realizing it. And, it's really easy to end up accidentally sort of walking over people's boundaries or bullying people in ways that you really don't intend. Like, you want to be really conscious of the fact that you have power of these folks, and you want to tread carefully. And so I think that's a really important thing to think about. Also, support your students as union. as people get in this sort of weird mode of thinking that the union is this like, this strange foreign agent that has entered into the university. It's just your students. It's just a big group of your students sort of speaking with one voice. Support your students. That's my faculty advice.
That is all great advice, Sarah. Can I challenge you one step further? Do you
Please.
have time management advice? So you talked about the need for time management. Do you have any useful tips for doing other than the coffee date thing, which is great?
I do believe in the coffee date thing.
Okay.
I think the biggest thing for me for time management, well, I've done sort of two things that I really like a lot. So I have particular times on my weekly calendar that I won't even check email. Like no kind of work is allowed in those times. And I'll like make a little bit of an exception if we're on a like fun deadline push, like whatever, like, this isn't a hard and fast rule, but sort of any week that looks like sort of a normal week, I'm not going to be working during those times. And so that enforces that, okay, all the other time has to be spent very productively, right? I can't be sort of frittering it away on random stuff.
Like you're not working at all, like you're doing fun stuff, or you're just
yeah, exactly. Yeah, so yeah, I'm doing whatever it is I want to do on my free time, right? I'm not doing work during those hours, which then enforces that I can't let my calendar be taken over by sort of random stuff that is not getting the stuff done that I need to get done, right? Because there's a fixed amount of the stuff that I need to get done. Maybe not even a fixed amount, maybe an infinite amount, but like there's definitely some things that have to get done. And so that had better get done in those other hours. And so I'd better not sort of end up having all this sort of fluff on the calendar. So that's been really helpful. And then the other thing that I have found really, really valuable is to make meetings for the things that I really want to spend more time on, right? So if I really want to be working on my students' writing, I will make meetings that are for that, where we are going to be sitting together and working on writing together, right? So rather than saying, oh yeah, I should really, think about that at some point, and I should really, work on their writing, right? That's, if I just sort of have it sort of written down on the paper planner or whatever, that's never going to get done. I have to put it on the calendar as a time where we are sort of obliged to meet together in order to sort of prioritize it and make it one of the things that I'm actually devoting time to and not letting other stuff take over. And so that sort of fills up the calendar again with the things that I really need to make sure that I'm doing. And so then it makes it that much easier to not fill it with the things that would actually be distracting. Hopefully that makes sense.
Wonderful advice. Yeah. You should write a blog post for.
I'd love to. That'd be great.
If you have the time. Yeah, I'll send you a calendar.
Yeah, that sounds great. Exactly. Yeah.
I could put whatever. You have no choice.
Good.
So I guess other advice for, let's say, young researchers, aspiring undergraduates. What do you have for them?
Okay, so I see basically two common paths for how PhDs go sad, which is getting locked into a project that you don't actually enjoy. Unfortunately, I don't have any general purpose of voice for avoiding that one. So that one's going to be a navigate that with your advisor situation. But the second one, I do have general purpose advice for. So the second way that I see PhD students sort of becoming sad, becoming disillusioned, like not enjoying the PhD, is if they become isolated. So go to lunch with your peers every day. And I know this sounds very sort of silly and it's just this one concrete thing. How can that possibly be the answer? And for some reason, every time I suggest this to someone who's complaining about isolation, they push back, right? They're saying, oh, well, I can't afford to go out. That's fine. Like, bring your lunch. Like, that's what I did every day of my PhD. I brought my lunch. Everyone brought their lunch. Or sometimes people were buying a sandwich and then we'd all hang out and eat. That's fine. Or they say, well, my peers aren't coming in. And then they'll say, you know what? It doesn't have to be your lab mates. Find any other, 4 or 5 people in the building, right? Like, grab someone. And I don't care if you're coming to campus immediately before lunch and leaving immediately after lunch, right? I'm not saying that you have to work from campus all day, but get lunch with your peers every day. Like, find some way to make that happen. I really, really deeply believe in this. And it's very hard to persuade folks, but folks should do this. So that's number one.
If you don't mind my just agreeing with that, I feel like there's a failure mode that can happen in grad school where if you don't do this, that is like if you don't build that type of connection, all you see are the external signals of other people's like progress through grad
Yeah.
school, and you don't get to see the sort of like the internal messy details that like make you feel less alone. You know, like you can really get a skewed impression of how grad school is going for other people if you like are just sort of watching them from afar, you know.
100%. Well, and it supports so many parts of sort of what you're trying to do, right? Like maybe if they're in your research area, you're ending up bouncing research ideas off each other, which is amazing. But maybe it's not even that, right? Maybe it's just like, oh yeah, that form is fine if it's 3 days late, don't worry about it, right? Like maybe it's just these sort of day-to-day, how to navigate life as a researcher, as a grad student, or sort of these sharing these reflections about what matters in your different areas and sort of how you're thinking about research right now, how you're thinking about it shaping your future direction, right? This kind of thing, you know, a lot of folks tend to think that the advisor is sort of the only source of this kind of guidance. And realistically, probably at least 70% is going to come from your peers. So make sure you have some peers, have some folks who you're comfortable enough, you have enough of those social bonds established that you can have those conversations. Yeah. This is also why I think it's important for the faculty to choose students carefully, because they are going to be teaching each other. And so yeah, think about that too.
Cool. Well, that's all we have for you. Thanks so much for your time.
Super fun.
Yeah, yeah, great advice.
Yeah,
And
thanks, Sarah. This is really great. It's like a great mix of the technical stuff and then also the advice stuff. It was super useful.
I really enjoyed chatting with y'all. This was a blast.
yeah, have a great weekend. Thank you.
Have a great weekend.
Bye.
Bye.